Okay, this is College Algebra, Unit 1, Notes 4, Exponent Rules. So first, looking at a definition, we have the word power. Power is an expression made of a base and an exponent. So to remind you, if we have the example of x squared, x is the base, 2 is the exponent, and x squared as a whole can be described as a power. The goal with these notes is to learn how to simplify expressions with the same base. So let's look at rule number 1. Rule number 1 is talking about the product rule. So it says when multiplying powers of the same base, we add the exponents. So notice here on example 1 and 2, we have 2 cubed times 2 to the 4th. So 2 on both of these are considered the base. And since they're the same, we are going to add the exponents. So this is the same as saying 2 to the power of 3 plus 4, which is 2 to the 7th power. Okay, same with the x's. They both have a base of x, so I'm going to add the exponent since they're multiplying. This becomes x to the power of 5 plus 2, which is x to the 7th power. Okay, next example, we have 4 squared times 4 to the 5th. 4 is the common base. We're multiplying, so I'm going to add the exponent. So this is 4 to the 7th power. Okay, now let's say we have coefficients in the front. So notice I have my same bases, which is x, but I also have some coefficients. So since I'm multiplying, I'm going to go ahead and multiply the coefficients. So 2 times 5. Then I'm going to deal with my bases. So my base is x, and since I'm multiplying, I add the exponent. So 3 plus 6. So this becomes 2 times 5, which is 10, and x to the power of 3 plus 6, which is 9. So my answer is 10 times x to the 9th power. Notice my coefficient I multiplied, but my bases, since they were the same, I added those exponents. Okay, rule number 2, the quotient rule. When dividing powers of the same base, we subtract the exponents. So looking at example 5, we have 5 to the 6th power divided by 5 squared. So the base is 5. We're dividing, so I'm going to subtract 6 minus 2. And this gives me 5 to the 4th power. Same with if I have variables. So I have y to the 9th divided by y cubed. My same base is y. 9 minus 3 for my exponents because I'm dividing. So this becomes y to the 6th power. Now what if I have coefficients? And instead of a division symbol, I have the fraction bar. So this says 10x to the 9th over 5x to the 4th. That's the same as saying 10x to the 9th divided by 5x to the 4th. So since I'm dividing, I'm going to treat these coefficients as if we are dividing. Okay, so 10 divided by 5 is 2. Okay, or I can write that as 2 over 1. X to the 9th divided by x to the 4th, I subtract the exponent, so 9 minus 4, and I get a positive 5. So since I got positive 5, I'm going to leave that on the top, so x to the 5th, which means this is the same as saying 2x to the 5th because I don't need to write over 1. Okay, same with number 8. So number 8, I really have the coefficients 1 and 3, because if you don't see something in front of the variable, it's that invisible 1. Same with the exponent. If you don't see an exponent there, it's an invisible 1. So I have 1 over 3. So think of that. That's the same as saying 1/3. Is 1 divisible by 3? No. So I'm just going to carry that over with my fraction bar and don't touch it, okay, because it can't simplify. Now I have m to the 5th power divided by m to the 1st power. So I do m to the power of 5 minus 1, which is m to the 4th power. And since it's positive, it's going to remain on the top. So I can rewrite this as m to the 4th power over 3 because I don't need that 1 in front of the m. Rule number 3, power of a power. So it says when raising a power to a power, we multiply exponents. So notice on example 9, this is 3 squared to the power of 4. Power to a power, we multiply those two numbers. So this becomes 3 to the power of 2 times 4, which is 3 to the 8th power. Same if our base is a variable. We still are multiplying those powers together. So this becomes a to the power of 3 times 5, which is a to the power of 15. Okay, now let's look at something a little bit more complicated. We have 5xy squared to the power of 3. Okay, we need to make sure that this power gets distributed to every single component inside of that parentheses. So really, if I was to rewrite this out, this is now 5 cubed x to the 1 times 3. Because remember, if we don't see anything, there's a 1 there. And then y to the 2 times 3. So remember, power to a power, we multiply. So really, this is 5 cubed xy to the 6. And of course, we can simplify that further. We know that 5 cubed is the same as saying 5 times 5 times 5, which is 125. But here we're just trying to get in the habit of using our exponent rules. Okay, number 12, we have 2x to the 4th power to the power of 10. So yes, this 10 is going to go to x to the 4th power, but it has to also go to the coefficient of 2. So this would be 2 to the power of 10 times x to the power of 4 times 10. This is 2 to the power of 10 times x to the power of 40, and that would be my answer. Okay, rule number 4, power of a product. So this is similar to what we were doing in power to a power. So it says when a product is raised to a power, each term gets the exponent. So it's more practice of what we were doing above. So this is x times y to the 4th power. So this 4 is going to go to the x and the y. So this is the same as saying x to the 4th power, y to the 4th power. Okay. Same with example 14. This 3 is going to go to the 2, so the y squared, and to the 3. So this is 3 to the power of 3 times y to the power of 2 times 3, which is, and we can even practice simplifying, 3 to the 3rd power is 3 times 3 times 3, which is 27, and then y to the 6th. So that would be our answer. Okay, rule number 5 is the 0 exponent. Anything raised to the 0 power is 1. So y to the 0 power is 1. It is not y to the 1 power. That is not the same thing. 125 to the 0 power is 1. 2x squared times y to the 0 power, that 0 goes to everything. Okay. So 2 to the 0 power, x to the 2 times 0 power, and y to the 1 times 0 power. Okay. 2 to the 0 power is 1, x to the 0 power is 1, y to the 0 power is 1. So this all is going to equal 1. Okay, last rule. Rule number 6 is the negative power rule. So if we have a negative exponent, that means to move the term to the other side of the fraction and make it positive. So for example, on number 16, we have x to the negative 4th power. We need to first turn this into a fraction by writing it over 1. Then I'm going to grab that exponent, and with its base, I'm going to move it down so it's positive. So this becomes 1 over x to the 4th power. Same with if it's on the denominator. I'm going to take this negative exponent with the base, and I'm going to move it to the top. When I do that, it becomes positive. So I have x to the 6th power over 1, or just x to the 6th power. Okay, so last example, a little more complicated here. Let's say we have all these different variables, x, y, and z. Okay, we have to use our properties of division, because it's a fraction bar, to subtract the exponents. But if the exponent is positive, it's going to stay on the top. If the exponent is negative, it will go to the bottom. Okay, so let's start with just the x's. This is x squared divided by x to the 5th. Okay, 2 minus 5 is negative 3. Well, I don't want it to be negative, so I'm just going to keep it on the bottom. Okay, x cubed. Now I do the y's. Y cubed divided by y. That's the same as saying y to the power of 3 minus 1, which is y squared. It's positive, so it's going to stay on the top. And then I have z's. Z to the 9 divided by z to the 10th. 9 minus 10 is negative 1, so it's going to remain on the bottom as just z. Okay, remember, we don't need to write 1. It's an invisible 1. Just write z. So that would be my answer.